Hello and welcome back to the tutorial. So in the previous tutorial we understood the basic concept of DNS or domain name system. We just understood the theoretical part. So now we're going to see the simulation, and I just want to tell you that to understand this tutorial and to understand all those steps, you need to understand the tutorials regarding ARP. So I hope you have already seen them, and so let's move on to DNS. So in case of DNS, you can see that I actually started this simulation by browsing from PC0, and I browsed www.test.com. okay, so when I browsed that website, two packets were created. One is ARP and the other is DNS. I have already shown in my previous tutorials the simulation of ARP, how an ARP packet actually works. Now I'm gonna show you the DNS part. So when ARP is done, then the DNS part begins. Okay, so initially both of the packets are created at the very first time, ARP and DNS, but then only ARP works at first, and when the functionalities of ARP is completely done, then DNS comes into work. So let's begin. So here you can see that the brown colored packet is actually the DNS packet. So let's just see what information is lying over there. So you can see that, yeah, right there. So there is a packet known as DNS Query. Okay, there are two packets, same thing basically. So I'm just gonna go on to the next, to the last one over there. So DNS Query. Okay, so I'm talking about this one. So this is known as DNS Query. So in this DNS Query, so I have searched www.test.com. so the name indicates the website which I am browsing, www.test.com, but you can see that it still doesn't have any kind of IP address related information over here. It has something like a type or TTL or class, etc. length, but it clearly doesn't have any kind of IP addresses stored over here. So it only has the name, it does not have any kind of IP address. So let's just show you what happens if we run this simulation. So I'm gonna just cut this one and I'm gonna run the simulation. So if I go further, one step further, you can see that my packet is currently at the switch now. So the packet moved from PC0 to switch right now, switch 5 here. And now let me ask you a question, that from this place, okay, so from this place, where should this packet go? Should it go to PC1 or should it go to server 0? Okay, so my question is that from this place, where should this packet go? Should it go to PC1 or should it go to server 0 or should it go to both of these places? Okay, so I'm gonna give you just 5 seconds to answer this question, then I'm gonna start again. Okay, so I guess you have already managed an answer within your brain. So what do you think? Let me just tell you what's gonna happen, and you can just match it with your own answer. Okay, so here let me just show you the simulation. My question was, where should this packet go? Should it go to PC1, should it go to server 0, or should it go to both of the places? Okay, so let me continue my simulation. You can see that the packet is only traveling to this place over there, the server 0. The packet is only traveling to server 0. So why is happening like that? Okay, so that's because there's absolutely no reason for this packet to go to PC1, because we have already identified where the specific destination should be. We have already identified using this ARP procedure, so we already know where the packet should go. The internet already knows where the packet should go, so it does not need to send this packet to anywhere where it's not needed. So it already when we ran the ARP, the internet didn't know where the packet should go. That's why the ARP was sent as a broadcast, and the packet was sent to all all the possible destination to PC1 and to server 0, but then it was able to identify that server 0 is its actual destination. So since now it already knows its actual destination is server 0, so there's absolutely no point of this packet to go to PC1. So that's why this packet only traveled to server 0. So hopefully you understood this explanation. So now this packet traveled to server 0. So let me just show you the PDU details over here. So you can see that there is the DNS query, and still there is only the name www.test.com, and there is absolutely no IP address written over here. So let me just show you the response. So now the server will respond something over to the switch again. So yeah, it is responding, and after that okay, so let me just show you the details of this packet. So this is a response packet right now, a response DNS, a DNS response right now. Okay, so now let me show you right over here that initially we only had DNS query. So what I'm talking about is this one, that initially I showed you previously that there is only DNS query and there is only the name of the website. There is absolutely no IP address written over here, but in the DNS answer you can see that here after the DNS query part over there, the DNS query part over there, there is another part which is written as DNS answer. Okay, there is another part which is written as DNS answer. Okay, so this is a new part. So just take a look at this new part over there. So here you can see that there is a name written right there, www.test.com. So this was the original query, that I want to go to www.test.com. so do you know the IP address of that website? So by applying DNS here, by applying DNS here, the DNS packet actually resolved this IP address over here. Okay, so that's why you can see that for www.test.com there is an IP address written over there, and the IP is 192.168.1.10. that means that if I want to go to www.test.com, then the data of those of that website is stored in the server which has the IP address of 192.168.1.10. in our case, this is the server where this website is stored. For example, if you want to go to www.google.com, then whenever you write the address in your browser and the URL of your browser, then whenever you hit enter, then the DNS runs, first the ARP runs and then the DNS runs, and the DNS helps helps your browser to resolve that name into an IP address by which the internet knows where to browse to. Understand? So here you can see that initially I wanted to browse www.test.com, and when the packet was sent to the server, so the server actually wanted to look that if the server actually knows the IP address of www.test.com. so since it knew the IP address of www.test.com, that's why it embedded the IP address of that website into its response packet and it sent it to the switch. So let me just show you another thing right here, that in the server configuration you can see right there in the DNS part. Okay, so www.test.com, so this website's IP address is actually 192.168.1.10. so what actually happens here is that whenever I wanna whenever the DNS runs, like, so let me just go into previous step. Okay, so whenever the DNS runs, so from switch to server, so this is a DNS query packet. So for the DNS query packet you can clearly see that there is only the website name www.test.com. so when this packet comes over here, then this this packet tells the server that my user wants to search www.test.com. so do you have the IP address for www.test.com? then the server looks into its own services, it looks into its DNS configuration, and it can clearly see that, yeah, okay, so the user wants to search www.test.com, and I have that information in my server, in my configuration, that this website has the IP address of 192.168.1.10. okay, so since I have this, so I'm gonna send it to as a response. Okay, so that's why when it sent a response, it actually embedded that specific IP address of that website into another new field of this DNS answer, which was not initially included in the DNS query. So after that, the response reaches to PC0. Okay, the response reaches to PC0, and you can see that there is a tick sign right over there. Okay, so there is a tick sign right over there, and I'm just gonna end the simulation right now. It's still not done yet, so I'm gonna press continuously on this button right over there until this comes. So this is just to end my simulation over there. So whenever I get this window over here, buffer full, then I'm going to click on view previous events, and then the simulation is done. And now you can see that I have this thing in my web browser. So this is the original web browser of PC0, from where I actually searched www.test.com. so you can just see my previous videos that when I searched this one and then I clicked on go, then nothing was shown here. But now, since I have completed the ARP part and DNS part, now you can see, since I have completed both of them, now here I can see my data over here. Hello to our data communication class. But yeah, I want to tell you that this is whenever we complete ARP and DNS, these are actually not enough to see the contents of a specific website. We actually do have to run some other protocols, especially HTTP. Okay, especially HTTP, we do need to run HTTP to get the contents of a website. But in our example, we're not concerned with HTTP, we're only concerned with ARP and DNS. That's why the HTTP part is completely hidden here, and you can see that the visible events right here are only ARP and DNS. I have not shown the HTTP. I have made it hidden, so that's why the HTTP part is not shown over there. And without the HTTP, we could not get this part. But since the HTTP part is hidden, but it is already running in the background, so that's how we actually got this part. And we're going to learn about HTTP in our next tutorial, hopefully. Okay, so this is how actually DNS works. So for DNS to work, first we do have to run ARP, and after the ARP, when we're sure that when we're confirmed about the destination device, that when we know the MAC address of the destination device, then we can run the DNS. So after knowing the MAC address of the destination, then the DNS runs. The DNS helps the devices to understand the IP address of the specific website name. So for example, if you want to search www.facebook.com, then the humans understand facebook.com, but the internet understands only IP address. So DNS actually maps facebook.com to its equivalent IP address by which the internet can run the user's query. So for our example, we actually searched www.test.com. so the query was sent from PC0 to switch, and then from switch to server, and at the server got this query, and the server looked into its configuration for this specific information, whether it has the information for www.test.com. Since it had the information, so it just embedded this IP address into the response packet, and then it sent it back to the PC0. And that's how the original sender actually knows which IP address it is actually looking for. So that's how it knows that which IP address is actually resembles www.test.com. okay, so let me just give you a bonus question right here. I'm gonna write it over there. Alright, so let me just ask you this question. So what happens if the website IP address is not included in server 0? So what I'm saying is that what happens if this server does not have this information over there, then what happens? So in that case, this server will probably have some kind of information like in that case this server will be connected to another server. Alright, so maybe something like this server may be connected to another server. Maybe this is the website server. Okay, this is the website server. So okay, so let me just write the whole thing. So website, okay, so maybe this is the main website server. So initially the query will be sent to this server, but then this server will forward that query into that server because it doesn't have the website information directly. So it will forward the information, forward the query to this server where the website information is actually stored. Then this server will send a response to this server, and then it will go back to the user again. So if there's something like that the website information is not stored in your local server. All right, in your local server it may be stored like 50 servers ahead or 100 servers ahead. In that case, your local server will send the query to another server, then that server will send the query maybe from maybe to another server, and that server to another server. So this process will go on, and this process will go on until that query is resolved, until it gets to a specific server which has that specific information for a website. So the query will continue until there is a server which has the IP address for that specific website, and then that server will send a response, and this response will eventually go into the original user. So that's how actually DNS works. So hopefully you understood this topic, and yeah, thank you very much.